Hello friends, it's time to deploy our backtested strategy to the real world. I hope you're excited. Before deploying your backtested strategy, there are certain important things that you need to take into considerations. Firstly, position size. If you recall, our backtesting was mostly based on pip. What is going to be our total pip return, maximum drawdown in terms of pip, etc. We did not really take the position size that we are going to have for every single of our trade. And that is something very important. Your position size is going to determine what is going to be your P&L or whether you're going to stay solvent or not to continue your trading. So position size is one of the most critical consideration, and we'll spend some time figuring out how to optimize the size of every single trade that our strategy tells us to enter or exit. Next, assets. Which assets are you going to include in your trading strategy? I mean, there is a universe of assets. If you're trading currency, there are over 100 currency pairs that you can trade. If you're trading equity, there are innumerable number of equities that you can include in your basket. So you would have to decide before implementing your strategy how you're going to select your assets from the universe of assets that are available to you to trade. And related to this is another consideration is that are there any asset specific parameters that you need to pass to your trading strategy? So for example, in the MACD support resistance strategy that we backtested, we saw that every single currency pair may have a different time frame under which it was performing well. So for example, some currency pair was performing better in 30-minute candles, some was performing better in 4-hour candles, etc., etc. So each asset is going to have different parameters in this case. In addition, each asset may have more than one parameters. So in the same example of MACD support resistance, if you recall, we also needed to know what is going to be the time frame using which we are going to calculate the support and resistance for that particular currency pair. So you see how complications start building up? So it's very important that you decide which assets you're going to include in your strategy and also how you are going to supply the asset-specific parameters to your trading strategy. And we will cover that before we implement our strategy. Third consideration is notification. A lot of people consider this as a luxury that, hey, my strategy is working fine, it's running. I don't really need to get every single notification whether my strategy put in a trade or exited from a trade, etc. However, I think that it is very important for you to keep track of what your strategy is doing and that things are not going awry. So you need to come up with an architecture wherein there is some kind of notification that you get, be it email notification or telegram notification or whatever, as soon as your strategy takes any action, for example, entering a trade, exiting a trade, etc. And lastly, what is your contingency plan? What fail-safe measures are you going to implement so that in case things go south, you do not lose your shirt? So things like disconnections, etc. are not very uncommon, and it's always prudent to have some kind of contingency plan of what you are going to do if something like that happens. You may not be even available at that time when that happens. So what is your contingency? Alright, so I will spend some time explaining a few of these considerations in detail, and some we will cover once we are actually implementing the strategy. Alright, so I hope once you transition from backtesting to deployment, you would take these considerations seriously. Thank you. Hello friends. Once you have completed backtesting a given strategy, you now have to implement it. And when you have decided to implement a strategy in the real world, one of the first and the most critical decisions that you would have to make is what is going to be your position sizing strategy. And what I mean by position sizing strategy is that how are you going to allocate capital to each trade in your strategy? So based on your strategy, you may get a number of signals, and based on those signals, your strategy may or may not initiate a trade. But when you are initiating a trade, what is going to be the size of that trade? And you should give careful consideration to how position sizing is going to be determined. There are a number of approaches that traders use across the world. Some of the popular position sizing strategies are fixed position size. I have a predetermined position size in my mind, and every trade that I'm going to place is going to have the same amount. Although I do not recommend it, a lot of people stick to fixed position sizing strategy. Then there is the very popular risk or P&L based strategies. In these strategies, we try to come up with a customized position size for each trade that will lock in the per trade P&L or per trade risk that we are willing to take. And then there are some sophisticated models for position sizing as well. For example, Kelly criterion, etc., which use fairly sophisticated and dynamic mathematical models to arrive at the position size for a given trade. But for the purposes of this course, we will be implementing a risk P&L based position sizing strategy, and our aim is that we would want to get a position size which would almost fix the per pip P&L that our trade would generate. And I'm mentioning almost because once you start implementing, you will see that you can never actually fix the per pip P&L for a given trade because the markets are moving, and as the underlying current price change, the calculations and the dynamics for per pip P&L at different price point would be different. So it is going to be a bit challenging, but I think we should be able to do a reasonably good job of almost fixing the per pip P&L movement. So in the next lecture video, we'll write a function that will achieve just this. So I'll see you in the next lecture video. Thank you. Hello friends. So in this lecture video, we will write a function that will get us a position size based on our per pip P&L requirement, which by default is $10. And if you recall, I had given you this as an assignment earlier in this course, and I hope you all took a stab and you have some kind of a solution. And it would be great if you compare your solution with the solution that we are going to discuss here, and let me know if there are any discrepancies or challenges in understanding the logic. Alright, so this is the function that we have to get. But first of all, let us try to develop an intuition. So let us take the symbol as USD/JPY, for example. So in this case, USD is the base currency and JPY is the counter currency. So let's say the exchange rate is 100. That means 1 USD gets us 100 JPY and the position size is 100,000. So we purchased 100,000 base currency, which is USD, and we paid 100,000 into 100, which is 10 million JPY. So let me write this down as well, otherwise we might get confused. So 10 million. Now, the exchange rate became 100.01. So how would we calculate the P&L? Let us calculate the P&L in terms of the base currency. So here the base currency is USD, so it's pretty easy because our accounting currency is also USD. So this makes things a bit easier. But let us say all the base currencies are USD. In that case, what would be the calculation? Again, think about it. We purchased 100,000 USD, but because the exchange rate has gone up, I have actually made money. So 100,000 into 100.01 is the value in terms of JPY of my current holding. What was the initial holding in terms of JPY? 100,000 into 100. Alright. So this is my current P&L in terms of JPY. But then I have to convert this into USD because I want to get all the information in the terms of USD. So what would I have to do? I would have to divide it by the current price, 100.01. So this here would give me the per pip P&L, which is close to $10. What would happen if none of this is USD? Let's say the symbol is AUD, NZD, Australian dollar and New Zealand dollar. What would happen in that case? Let us quickly see that as well. So let me push this down. So let's say the exchange rate is 1. Once again, the position size, let's say, is 100,000. So we purchased 100,000 worth of AUD. So likewise, we'll also have to purchase 100,000 worth of NZD. I added an additional 0. Sorry about that. Now the price has become 1.0001. So for AUD NZD, the pip is 0.0001, unlike in USD JPY when it was 0.01. By now, I hope all of you are very comfortable with the concepts of pip and how it changes for different currencies pair. So in this case, what would be the P&L in terms of AUD? Again, AUD is the base currency. So calculating the P&L in terms of AUD is going to be fairly straightforward. Our current holding value is 100,000 into 1.0001 minus 100,000 into 1. So this is a total P&L in terms of the New Zealand dollar. So we'll have to convert it into Australian dollar by dividing it by the current P&L, which is 1.0001. Alright, but in this case, this is not the final answer because this value is in terms of AUD. So we will have to convert this value into USD. So let me first run this and show you what is the value here. Sorry about that. Okay, so again, it's $10, but this is 10 Australian dollars. So we'll have to convert it into USD. So that is very straightforward. We'll have to get the current exchange rate of AUD USD and then convert this into USD. But based on that conversion, your position size would change because 100,000 would not work anymore to get $10. This size would change. Alright, so I hope we have developed a good enough intuition. So let us start implementing the solution. Let me push all this down. I want to keep this here so that you can refer and compare what we are doing. The logic is going to be the same. So the first thing that we'll do once we get the symbol is get the base currency. So that's going to be fairly straightforward. It is a Python string and all we'll have to do is get the first 3 letters to know what is our base currency. So it is going to be symbol, give me from the start till the index 3, not including it. Alright, so this will give us the base currency. So the next thing I want is the symbol data. If you recall, there is a very handy API called get symbol info, something like that. Symbol_info. Let me double check if this is the API call. Yeah, symbol_info. And here I will pass symbol. Just to ensure that we are understanding the code flow, let me pass some sample values to these parameters so that we know what is going on. So if I run this, I will have the value of symbol variable. Likewise, let me also populate the value of these variables because we are going to use them. So now base currency is AUD. Now symbol data is going to be all the data. Oops, I'll have to instantiate MT5 and authenticate ourselves. So why don't I simply copy all this portion of the code that we have been using in all our codes, right? So let me quickly do that. All right, so we have established the connection. So now we should be able to run this line of code. We have got symbol data. If I run this, this is all the data pertaining to AUD and ZD. Next thing, we require the pip value as well. For most of the currency pairs, it would be 0.0001, but it could be different for different currency pairs as we already know. So let us find this. If you recall, we had created a function getPip for a given symbol. You can copy that function here and work with it. Although since we already have the symbol data, and if you recall, symbol data gives us a value called point. You can just search for it somewhere, and 10 times point is 1 pip. So why don't we use that to get the pip value? So 10 into symbol data dot point. If I run symbol data dot point, I should see 0.00001 because this is AUD and ZD. 10 to the power minus 5. So if I multiply it with 10, we will get the pip value for AUD and ZD. Now if you look at derivations that we had done as an example, you will see that we'll have to divide the P&L with the current exchange rate. So we would need the current exchange rate as well. And if you recall, when we were discussing the symbols related API, we had created the getCurrentPrice function. So all I'm going to do is copy this function and paste it in our code because we are going to use getCurrentPrice for whichever currency we are interested in. So if I run this line of code, of course it is not defined because I have not run it yet. If I run this line of code, I will get the current price for this symbol. Now per pip P&L should be fairly straightforward. We have already derived it below. and this per pip PNL is going to be in the base currency. So if it's AUD, the per pip PNL would be in AUD. Now let us look at these numbers. So if you do the math for the numerator, it is essentially 1 pip. N times 1.0001 minus N times 1. If you take this difference, it would be 1 pip. So numerator in each of these instances is nothing but 1 pip. So numerator would be 1 pip, and we will divide it by the current price plus pip. So here, let me call it current price. So this would be current price plus pip. Now we've got pretty much everything. All that we'll have to find is position size. So now let us see what is going to be the equation, because we are going to require some algebra to get position size. So first of all, we are going to have lot size times position size. So if my position size or volume unit is 1 and lot size is 100,000, then this would be 100,000 times per pip PNL, and this should be equal to whatever is the required per pip PNL, right? So simple unitary method, we have per pip PNL, we want to know by how much we should multiply to get this particular value. So position size would be required per pip PNL divided by lot size into per pip PNL. So let's do that. So position size is equal to required per pip PNL divided by lot size into per pip PNL. So lot size into per pip PNL. But as we have already discussed, this position size is not correct because our required per pip PNL is in the USD and not in base currency. So we will need to find out the USD conversion factor. So we would have to create a function, but we'll do that in a bit. But first, let me create a variable called USD factor. And this would be equal to, we'll have to define a function. Let's call it USD conversion factor or something like that. And then we'll pass the symbol. Okay, so let me remove this right now. I don't need this anymore. So we will create this function in a bit. But where would USD factor feature in this algebraic expression? We will have to multiply the left-hand side with the USD factor, alright? So this value that you see here, everything before USD factor is the amount in the base currency. So we need to convert it into USD, and that's why we have the USD factor, and this would be equal to 10 or 5 or whatever USD is the required per pip PNL for us. Okay, so this equation here would have to be altered slightly. We will have to multiply USD factor to the denominator. Alright, so everything is done. All that we need to do is define this function, USD conversion factor. So let's do that. So define USD conversion factor, and it's going to be a bit tricky, and I'll tell you why. And the thing that we are going to pass here is base currency. So for example, if base currency is AUD, then we would have to get whatever is the factor that would convert the given AUD amount into USD amount. So let me call it currency. This would not be symbol because symbol is a combination of two currencies. Here, we only have one currency. First of all, if currency is equal to USD, and there is a possibility because a number of currency pairs or symbol have USD as the base currency. If this happens, we'll simply return 1. If that doesn't happen, then we'll have to start our monkey business. First of all, let us get all the currency data. So this is the symbol info data for every single symbol available to us to trade. And if you recall, the relevant API call for that is symbol info. We have discussed these API calls in detail, so I expect that you have familiarity with these API calls. And here, I'm going to filter my search. I'm not going to get all information for every single currency pair. I will only get information if the currency pair has our currency as either base or counter currency. Alright? So I hope you recall how to do that. We'll have to use wildcard search here. So within the string, we have to mention JPY or USD or whatever. But here we have a variable called currency. So let's have a placeholder, and then let's end this with another wildcard operator asterisk, so that either the symbol starts or ends with the base currency we will still extract all the information. Dot format currency. Alright, so let's quickly check whether this would work or not. So let's say currency is AUD. Okay, let's remove this. And now if I run currency data, oops, I've got a none here. Have I used the right API call? Let me quickly check. I may have confused between API calls. Okay, so it's actually symbols underscore get. To get all financial instruments, it is symbols underscore get. Symbol underscore info is for a specific currency pair. So sorry about that. I mixed up between these two. So it would be symbols underscore get. So if I run this, now I should be able to get all the currency pairs with AUD as either base or counter currency. So you see there are 17 such currency pairs. Alright, so I have got the relevant data. But now I only care about one currency pair, which is whatever is the base currency with respect to USD. I don't care if it is AUD GBP or AUD Euro. I want AUD USD or USD AUD, whatever is available. So all that we have to do is look up each of these symbol info objects and try to extract the relevant symbol that we are interested in, which is either AUD USD or USD AUD. So for symbol in currency data, so we will iterate through each of these symbol infos, and we all know how to extract relevant information from symbol info. To get the name of the symbol, we have to use symbol dot name. I think we just extracted one symbol info here. Name is equal to AUD NZD. So we want to extract the name, and if either the first three characters is USD or the last three characters. So let me copy this and change this to 3 to end. If that is equal to USD, then that means that particular symbol info is the symbol info that I'm interested in. So if that's the case, base currency is equal to whatever is the first three characters, and then counter currency is the last three characters. Alright, so this is fairly straightforward. We should all be fairly comfortable with this. Why am I getting an error here? Invalid syntax. What did I do? Okay, I missed the if here. And this is the only thing I require. I want to know the base currency and the counter currency. So since I have been able to find base currency and counter currency, I am going to break out of this loop. And once again, it's very important to identify the base currency and counter currency. And that is the challenge I mentioned at the outset. Because when you are trying to find the exchange rate with the USD can either be base currency or counter currency based on what symbol you are working with. So for example, in USD JPY, USD is the base currency, but then you have examples of Euro USD, where Euro is the base currency. So it's very important that we identify whether the base currency is USD or not. So that's what we have done here. We've got base currency and counter currency. So now that we have the base currency and the counter currency, let me get the current price. Current price is equal to get current price symbol. So let me copy this, and then symbol is simply a combination of the base currency and the counter currency. These are Python strings. We can add them. So base currency plus counter currency. Now we have got what we want, but then this is not the only thing. The conversion factor to USD would depend whether USD is the base currency or counter currency. So if base currency is equal to USD, then return 1 by current price. Okay, let me explain to you what I just did. So for example, let's take USD JPY. So the current exchange rate of USD JPY is 142.326. So if I have 1 million JPY and I'm looking for a conversion factor, then the conversion factor is going to be 1 divided by current price because USD is the base currency. Had this been JPY USD, then the conversion would have required us that we multiply the amount with the exchange rate. So that is what I'm doing here. So if it is not the base currency, then simply return the current price. Because that is what we'll have to multiply with the amount to get the corresponding USD amount. Let me quickly check this function whether this is making sense or not. We all know the ballpark estimate of various exchange rates vis-a-vis USD. So let's quickly check this. So get USD conversion factor. Let us do it for JPY. So if you have 1 million JPY, and you want to convert it into USD, I would assume that you would have to multiply it with a number smaller than 1, because more than 100 JPY is 1 USD as of end of 2023. So if I run this, I've got 0.007, which is making intuitive sense. Let us do it for another currency, AUD. So if you have 1 million AUD, you want to convert it into USD. Again, at the end of 2023, AUD is weaker than USD. So if you have 1 million AUD, you will have lesser USD. I would expect the conversion factor to be less than 1 again, but it would not be so less. It would be in the first decimal places, I guess. So 0.67345 makes sense. Now let us test it for a currency which is stronger than USD. So let's go with GBP. So GBP, so if you have 1 billion GBP, the corresponding conversion in USD would be more than 1 billion if USD. So let's see, I would expect the conversion factor to be 1 point something, 1.26. So this function is making intuitive sense. So let me make some final changes to this function. Why am I getting this error? Base currency is not used. Okay, so base currency we'll have to use when we are using the USD conversion factor. And then current price is assigned but never used. I think I've made a typo. So current price. I think this should work. And now let us quickly test it. So get position size. Let's start with USD JPY. So if you are trading, you would have to use a volume of 1.423745. But I think we'll still have to make one change in this function. And can you tell me what? Do you recall I had warned you that there is some problem with this volume unit? Volume unit has to be compliant with the minimum step allowed for a given symbol. So if I recall, for most currency symbols, it is 0.01. So we'll have to round it to 2 decimals. And I'll do that in a bit. But let us quickly check for some other currencies. AUD and ZD 1.6. So this is all making intuitive sense. Let us make this last change so that we don't get error that the volume is non-compliant. So we already have symbol data, and within symbol data, there is this thing volume min, volume max, and volume step. So this volume step is what we are interested in. So this conversion would require some gymnastics here. So let us see how we can do this. So for example, we saw that for AUD and ZD, we are getting 1.6006. So let me copy this value and let us see how we can convert this to 1.60. And the volume min is 0.01. So symbol data dot volume min is 0.01. So if I divide this floating point number by 0.01 and find the quotient, then what will I get? If I run this, I'm getting 160. So all I'm doing is that I am taking 0.01 and I'm finding out how many increments do I need to do so that I get closest to this number. There would be some fractional remainders. I don't care about that. 160 times 0.01 would give me my volume unit. So what I'm going to do is that I'm going to wrap this number in a bracket, and then I am going to multiply this number with 0.01. But there's going to be a problem in this as well. Let me show you. Okay, so in this case, I didn't get this problem. But let's say, for example, this was 1.64461 or something like that. Let me show you what would have happened if I run this. I would have got this number, 1.6400000001. So pretty much every programming language does that. And you can look up why this happened. This is a problem with floating point numbers in pretty much every programming language. And you may get these trailing zeros if you are working with floating point numbers. So we'll have to do some monkey business to get rid of it. Rather than multiplying it with 0.01, if we divide this by 100, then it would be fine. So what I'm going to do, that I'm going to divide this whole thing by 1 divided by 0.01. If I run this now, then I would get 1.64, alright? So we'll have to do something similar here. So all that I'll do here is that I will return position size. I want the quotient when I divide it by symbol data volume min, and then I am going to divide it again by 1 divided by symbol data volume min. Alright? So this should fix the problem. So now if I run this part of the code, I'll get 1.6. Alright, so this is where I'm going to end this lecture video. Go through this function, play with it, test it for a few symbols, and let me know if you encountered any issues or if you have any doubts. Just want to add a quick footnote to this lecture. I actually tested this function. So I have a test strategy that is running on the DarwinX platform. These are all the orders that I have placed, and you can see that these volumes or the order sizes have been calculated using the function that we just saw. And let us see whether the per pip P&L is as per our expectation or not. So this USD CAD trade, we entered at 1.3304. We exited at 1.3319. So almost 15 pips move. And the profit is as expected around $150. Let's quickly look at a few others, the ones where we lost money. So we entered at 141.96. We exited at 141.93. This is USD JPY. So this is almost 2.3 pips. This is 0.96. This is almost 0.94. So as expected, we have got the loss of around minus $23. Okay, so I just wanted to show you that I have tested this function and this actually works. So let me know if you have any questions. Thank you. Hello friends. At the start of this section, I gave you something to think about, and that was which particular currency pairs you are going to use from the universe of every single currency pair that is provided by your Forex broker. Now, this is not an easy question to address. Different traders have different approaches. One could simply just pick some currency randomly, put it in a backtesting code, see how it is performing, and then include it within the strategy. Or some people may simply look at the most widely traded currency pairs and just pick the top 5, 6, or even 10 and include them in the strategy. However, a decent approach to picking the basket of currency pairs that you want to include in your strategy could be performing a correlation analysis. Now, what is correlation? Correlation means how closely two different assets move with each other. So, for example, if I say that USD CAD currency pair and Euro GBP currency pair are closely correlated, so that means that the returns of these two currency pair, if we just chart them, they would mostly be very close to each other. And there is a statistical way by which we can quantify this relation. And I'm sure most of you know that. So that is called calculating the Pearson correlation coefficient for those two time series or whatever you're trying to find correlation for. And if that correlation is close to 1, then we say they are highly correlated. If that correlation is close to 0, then we say that there is almost no correlation. If it is -1, then that means that they are inversely correlated. The correlation coefficient ranges from 0 to 1 or -1, and that determines how strongly or weakly two assets are correlated. Alright, and we are going to use the historical data function that we created some lecture videos back to extract historical data of some currency pairs and then perform a correlation analysis and see which currency pairs pick our interest. So ideally, you want to have loosely correlated currency pairs in your strategy. And why is that? Well, that is one of the basic rules of portfolio management. The assets that you have in your basket should not be very highly correlated with each other. Because think about it. If you have 5 or 6 very highly correlated assets in your basket, then essentially it means that you are simply compounding your return. If one asset is getting a 5% return, now because you have 5 strongly correlated assets, your total return would be close to 25%. So that means you have simply multiplied or amplified your one asset return by 5 times. Likewise, if one asset performs poorly, that means if it has a return of -5%, then you end up having -25% as the overall return. So just to diversify and have a better risk to reward profile, it is recommended that your portfolio is comprised of weakly correlated assets. So we'll try to do the same. So what I'm trying to do here is that I will first get some currency pairs that I want to test for correlation and see which one of them have low correlation with each other. So one way to do this could be getting every single historical pair that your Forex broker provides you so that you can get using this command MT5 dot, I think it is symbols dot get. Yeah, this one. Let me first instantiate our MT5 object and run all this code. Okay, I don't really want to get historical data right now. Let me comment this out. Right now, I just want to see all the symbols. Alright, so we have got 139 symbols. That's quite a lot. And if I extract historical data for every single one of them, it might take me some time, and even MT5 will not be very happy about it, because that would mean requesting a lot of data using the API call, and they may throw a hissy fit or something like that. So you know what, let me get a list of 12 or 15 symbols. Alright, so I've got a list of 12 symbols. Actually, if you want to get the symbols from this API call, there is actually an easy way to do that. Let me show that to you. So let me first see symbols 0. Let me see the first value of this tuple. We should get an idea of how to get Forex. So you see the last part of this entire message. Path is equal to Forex / Euro USD. So there is a possibility that your MT5 broker provides you something other than Forex. So let's get every single currency pair, which you can find it under the name value within this symbols variable. So how do we do that? Again, I'll use Python list comprehension. So I for I in symbols. So essentially, this means that I'm going to iterate through every single value of this tuple. And what is the condition? This path should contain Forex. So if Forex in I dot path. So this I is a dynamic variable which will take the form of every single of these 139 messages. So all that I'm doing is that I am iterating through this tuple. Every time you see Forex in the path key, then give me the name key. Alright, I dot name. So if I run this now, so there's actually 122 symbols. And these are all your symbols. So once again, even 122 is a lot. And I'm not sure if MT5 will be happy if you just want to extract historical data of all these 122 symbols in one go. So that's why in this lecture video, I'm just going to do it for these 12 hand-picked symbols. If you want, you can give this a try. Use these symbols instead and see whether you get it or MT5 demo server crashes. I mean, demo server would definitely crash, but if you have a paid account with a Forex provider, they might actually give you the data. So now we have the symbols. Now let us get the historical data for each of these symbols. So for symbol in symbols, before that we need to define an empty data structure where we will be storing all this historical data. So what I'm going to do is that I am going to store only the close price because I need just one of the prices to calculate correlation. I don't really need every single information that is provided by the historical data API. That means open, high, low, close, and whatnot. I only need the closing price. So let me initiate this data frame. So this data frame would look fairly simple. The columns would be every single of these symbols, and then the rows would be the close prices for every single date. Alright, so this is what it's going to be. Now let's create a temporary data frame. So temporary data frame would be get hist data. Here it would be symbol, and the time frame that I want, let's do it for 1 day. And then number of candles, let us do it 1000. We want to see over the past 1000 days which of the currency pairs were the lowest correlated. Alright, so once you get the temp, hist data cpdf, the column would be symbol is equal to temp dot close. The name of the column is close, if you recall, C being small. So this should give us the data frame that we are looking for. So let me run these lines of code and let's look at our data frame. Alright, so I've got USD CAD, USD JPY, all of them, starting from 5th March 2020 all the way till the starting of 2024. Alright, so now we have got the data, but this data will not help me calculate the correlation. For correlation, we need to calculate the returns because we want to see how the returns are correlated, because no reasonable analysis could be done using the levels of the prices. For example, Euro USD could be 1.5, whereas USD JPY could be 100 point something. So just looking at levels would not really help us perform any meaningful analysis. So we need to get the returns. So calculating returns is fairly straightforward in Pandas data frame. Let me call this variable historical data CPDF return. And anyone know how we can do that in one line of code? Well, if you know Pandas, you know there is a very good function called percentage change. And this function essentially does that. It finds the percentage change from one row to another. Alright, so if I run this, you can see that you've got the daily returns. Now, I don't like this nan column on top, and that makes sense because when you are calculating return, there is nothing to calculate in the first row because there is no reference point to calculate the return. So the first row is always nan when you're calculating returns. So let us drop that. So hist data CPDF return dot drop na in place is equal to true. Alright, so from 1000 rows, we now have 999 rows. Alright, and then the magic of Pandas, we can do the entire correlation analysis using just one Pandas command, which is .corr. And if you want to read the dot string, this is it. Computes pairwise correlation of columns. It excludes nan values. And then these are the parameters. There are various methods that you can use to calculate correlation. By default, it is Pearson correlation coefficient, which is by far the most popular way of calculating correlation coefficient. So that's what we are using. If you want to use any different method, you can pass that argument method and then mention whichever method you want to use to calculate correlation. In this case, I am not giving any method. So let me store this correlation in a correlation matrix. So I'll show you how this thing looks. So if I open correlation matrix, this is the correlation matrix. So whatever columns that you had in your data frame, the rows would be the same. Alright, so this would be an n by n matrix. The diagonal will always be 1 because the diagonal corresponds to the column and row being the same symbol. So obviously the correlation would be 1. But if you want to interpret any other correlation, just look at the column and the corresponding row. So for example, the correlation between GBP USD and USD CAD is minus 0.6095. Let's look at some of the highly correlated currency pairs. So Euro USD and USD SEK. Yeah, makes sense. So USD is the common here. So essentially what you are trying to see is Euro versus SEK. So Euro and Swedish krona. So obviously I would expect a lot of correlation between the Swedish currency and the Euro. So this high correlation makes sense. Likewise, if you see AUD USD and USD CAD, so this is essentially the correlation between CAD and USD. And again, this doesn't surprise me. Both Canadian and Australian economy are highly commodity driven. So there tends to be a high correlation between their currency as well. So I'm not surprised. But we see some of these having very low correlation. AUD NZD USD CAD minus 0.18. That looks very good to me. Right? So you can do something like correlation matrix, absolute correlation matrix less than 0.3 or 0.2, whatever you want to use as a cutoff. So let us see what we get for that. Okay, let me close this and let me get CM. So you see that we now have a few candidates, GBP USD, AUD NZD, correlation coefficient of only 0.08. That's very interesting. Likewise, you can see some candidates to be included in your portfolio. This is just one approach which you can use. And I also wanted to introduce you to correlation analysis because a lot of forex traders like to use correlation in one way or another in this strategy. So it's good that you know how to quickly calculate correlation. You may want to change the time frame and look at correlation for different time frames as well. But this is a viable strategy that you can use to pick the currency pairs that you want to include in your strategy. If you are interested in pair trading, which a lot of forex traders do, then you would definitely need to use correlation, because in pair trading, you want to find the divergence between two highly correlated assets, because the idea is that the divergence will mean revert. So for those strategies, you would definitely need to know correlation. So it's very important that you understand what I did in this lecture, and let me know if you have any questions. Thank you. Hello friends, and welcome to a very interesting lecture, which is about sending notifications to your email, which is about your strategy sending you notifications. So there are a lot of ways you can send notification to yourself using emails or Telegram or WhatsApp or even web notifications. Python has a number of very powerful libraries that can help you achieve any of the notification protocols that you want to follow very easily. However, in this lecture video, I want to stick to email notifications because I find them to be the most reliable, and we also have flexibility of sending longer notifications if required. One thing I want to clarify at the outset is that you can use any email provider, Gmail, Hotmail, Yahoo Mail, whatever. I am going to use Gmail, but the problem is that many a times these email providers can make the authentication a bit difficult. And that is because applications accessing password and then using the email service to send bulk emails is something that the email providers are a bit skeptical about. And that is why time and again they keep enhancing the authentication protocol that is required. I try my best to keep updating it if the authentication protocol changes. However, if I don't do it, it would be great if you can go out and find the solution and the resulting change that you require to make to the code. Alright, so with that, let us start implementing our notification system. So the Python library that we are going to use is SMTP lib. I don't think you have to install this library. I think this is a Python native library, but just check it. And a pop quiz for you. Do you know what is SMTP? Have you heard this before? So just like HTTP and HTTPS are web-based protocol, likewise SMTP is the protocol that internet uses to send email information. You can look it up if you're interested. It's a fairly interesting thing. But right now we don't need to go into the depth. So SMTP lib helps Python do the same thing that an email client lets you do, that is sending emails. So first of all, what we need to do is that we need to instantiate SMTP lib's SMTP object. So this object takes in the argument of which mail service you're going to use and which port in your machine is going to make that communication succeed. Again, these are very technical details. And if you have studied network engineering, you would understand what I'm talking about. But once again, you don't really need to know about that. All that you need to provide information is which host you're going to use. So I'm going to use Gmail as the host. So I will be using my Gmail account as the account from which I will send an email to another account. Another account is also a Gmail account, but I don't really care about that. What is important is from which account you are sending the email. For Gmail, this is what we have to enter, smtp.gmail.com, because this is the host that pertains to the Google email service provider. Alright, and then the port number is going to be 587. Again, even if you use other email client, I think 587 should still work. But if it doesn't work, just look it up. There are a lot of people who provide answers of what should be the right port number for a given email service provider. Right, and once we instantiate it, we will have to use a function called start TLS. If you look into the doc string, it says that it puts the connection to the SMT server into TLS mode. Again, very technical thing, and don't worry if you do not understand what it says. Just think of it as another security layer. If you want to encrypt your emails, etc., you can do it at this stage. Right now, I don't really want to encrypt it, so I'm not going to worry about that. Next step is the most important, which is authenticating your email account. So obviously, you will have to provide your Gmail ID and then your password. The thing is that your regular password will not work in this case. You will have to provide app password. And I'll tell you in a bit how to get your app password. But here you will have to give your email ID and your password. I'm going to create a function, so let me do that. Send email, and then the arguments I'm going to pass here is the email ID, your app password. Let me change this password to app password, and finally, what message you want to send. Alright, so these are the 3 arguments that I'm going to pass to this function I'm going to create. Let me indent this. Alright, so that's taken care of. So now let me take you to Gmail and show you how you can generate your app password. Okay, so just search for Gmail app password and you will get the relevant link. So signing into Google app password, this should work. It will ask you to enter your regular password to authenticate yourself. Some people have a number of emails. So make sure you click the drop down and select the right email ID from which you want to send emails. So let me authenticate myself. Alright, and this will take you to your Google account's app password page. So all that you have to do is write the name of your app. You can just put any random name, it doesn't really matter. And then click on create. That's pretty much it. And if you see, app passwords are used to sign into your Google account on apps and services that don't support modern security standards. This is the reason why these email service providers keep making it more difficult for developers like us to use their service to send emails using programming languages. But that's fine. It's just that we'll have to keep pace with any changes that they do and everything should be fine. Alright, so just put any app name here, click create. It will give you a password that will look something like ABCD space PQRS. So it would be a 16-20 letter password. Just store it somewhere safe. And then the last step is using the function send mail, this one. Alright, so from address to address message. Actually, let me also make this an argument to email ID. Alright, so from address would be my email ID, to address would be to email ID, and then the message would be message, and that's pretty much it. .quit. Let me add this send email function to our utility function code, and I'll make all these email ID, app password, to email ID as default arguments so that I don't have to show it to you. And then the only thing that I'll pass is the message. Actually, let me make this message as the first argument. Everything else would be a default argument. So let me quickly move this to the utility function. I will import it here and then I'll show you how it looks. Alright, so let me quickly do that. Alright, so I have done that. So all that I'll have to do is import utility functions. So let us first change the current directory to where the utility function is stored. Alright, so I have imported send email from the utility functions. So all that I'm going to do is that as soon as the connection is established, I am going to send email, and the only thing that I need to pass is the message. So message is going to be connection established only. Alright, so let me first run till this line and see whether we have been able to import everything or not. Right, no problem. So now let me run these lines of code and let us see whether we get an email or not. Alright, and sure enough, you can see that I've got an email. There is no subject, but if you go into the body, it says connection established. Let me show you the sent email of my other email account. And once again, you can see that I sent an email with no subject. Alright, so adding subject etc. is very simple. I want you to spend some time and figure out what you will change in the function so that you also display the subject. When I will upload the code, I will add making subject as part of the email available to you as well. But it would be great if you want to spend some time and figure out if you want to add any other things to your email text. So the send email is something that we are going to use a lot. Once we get to actually deploying our backtested strategy, you will see that every time we get a signal, I will use this send email function and I will provide an explicit message so that when I get an email, I understand what is going on. Alright, so I hope you like this lecture video. Let me know if you have any questions. Thanks a lot. Hello friends, we now have all the tools required to help deploy our backtested strategy for real-world trading. And that's precisely what we are going to do now. Whenever you're deploying a backtested strategy, your starter code should always be the backtesting code, because the logic etc. would remain the same. However, we will still have to make some large-scale changes to the backtesting code And I'll cover the changes that we need to do in a systematic way so that we have a structure when we are converting a backtesting code to a strategy implementation code. Alright, so let's start from all the supporting functions that we had imported into backtesting code and see what we still need and what we can get rid of. So from the utility functions, we would still need to get historical data, hill valley, pip, current. I think everything here would still be required. Just one thing, if you recall, I had told you that when I'm actually deploying the strategy, I'll not use get historical data function. Instead, I'll be using the function that we created, which was time zone agnostic. Alright, so this is the function that I'm going to import. Alright, so that's taken care of. In addition, we have also developed a few additional utility functions that I said that we would use once we get to the deployment. And one of them were get position size, which is one of the most important functions for deployment. Without this, we won't be able to place orders. So let's import this. And also, we discussed sending emails to ourselves once an event occurs. So let us also get the send email function. From technical indicators, we will only need MACD, so that's fine. We don't need anything to do with strategy evaluation. This is a very backtesting thing, so let me remove this. Alright, and one more thing is that I have moved the utility function script and the technical indicator script to the deployment folder, so let me change the path as well. Alright, so I have changed the path to the relevant folder where all the materials pertaining to strategy deployment code would be stored. Nothing needs to change here. We'll establish the connection. We'll authenticate ourselves. No issues. Just make sure that you are using the key file of the actual platform that you want to deploy on. So whichever MT5 compliant broker you're working with, just make sure that you use that broker's key file and authenticate yourself appropriately. Okay, so in the backtesting code, we had been providing symbols one by one. And also for each symbol, we were providing what was the backtesting time frame and what was the support resistance time frame. This will have to stop because now we are going to trade on a number of symbols and each symbol may have a different backtesting and support resistance time frame. So for example, with AUD, USD, I may want a backtesting time frame of 4 hours and support resistance time frame of 1 day. But with USD CAD, I may want a backtesting time frame of say 8 hours and support resistance time frame of 12 hours. Okay. So depending on your backtesting, whatever parameters gave you the best result, you may want to have different backtesting and support resistance time frame for different symbols. And this is what we call input parameters. Every symbol that you are trading may have different input parameters. So rather than hard coding these into the code, we will get into the habit of generating a params file. So let me show you a sample params file which I have created for this particular strategy deployment. Alright, so this is how my parameter file looks. It's a simple CSV file, 3 columns, symbol, backtesting time frame, and support resistance time frame. Just make sure there is no typo because this is the exact string which will be read by your Python code. So make sure it's the same thing that you would have used had you been hard coding it into the code. Alright, so I just put some sample backtesting and support resistance time frame values here. So this is the file that I'll read into my Python script. So let me show you. Alright, so first of all, just mention whatever path this parameter file is stored in. I have stored it in the same folder where everything is, so that's not really a problem for me. But in case you have this param files saved somewhere else, make sure you give the correct path. Alright, and then all that we'll have to do is read this params file using the simple read CSV function of pandas. Have I imported pandas? No. So let me quickly do that. So pd.readcsv, whatever is the name of the file, params.csv. So let me show you how this thing will look. Okay, so you can see that I've got the params here. It's a data frame. We have the symbol, backtesting time frame, and support resistance time frame. And I don't really need all this anymore. So let me remove this. So symbol, earlier we were hard coding it as one symbol. So symbols would be params dot The column name is symbol, and I like to convert things into list, so to list. So if I run this now, you'll see that I've got these symbols. Because one thing, I will change this key to key.txt because right now there is an actual strategy running on my Divinix platform. So I want to run this code to provide some demo. So I might run this. And if I try to authenticate on my Divinix platform, I will lose the previous connection and my strategy would be hampered. So therefore, let me give the key of my demo account. I hope that's okay with everyone. Okay, and the scan rate data and all we don't need because if you recall, this scan rate data was historical data going back 1 year or whatever. I don't really need all this. I will do extraction of data and calculating of technical indicators within our strategy function. Let's wait for that. We will need the find support resistance function. So we're getting an error here because we had used get historical data function here. This will change to get historic data numeric index. That should be fine. Okay, a lot of this will change, but I would still need this logic. So let me not delete this part of the code. Let me push it down. So what else would we need when we are deploying? We would definitely need the functions to place our orders. So I already have the code that we had put together in the order section of the course. So the two orders that we'll be using would be placing bracket order, not pip, but the actual price level, because if you recall, we have support and resistance. So we have the absolute stop loss and take profit price levels. So we'll use this function. So let me copy this function and paste it. And for closing, we would want the close position function, which is a very simple function. All right. So these are the functions that we would need to have within our strategy deployment code. Once again, you can move these functions to utility, but I leave that to you. Okay, now let's get to the strategy. Let's define the actual strategy, the flow of how you will import the data, do the calculation, generate the signal, and place orders. So you can call this function strategy or main, whatever you want to do. So let me call this main, and I will definitely have to pass the symbol. So for each symbol, we will perform the calculations, and other arguments we will see as we are constructing this function. As and when we require an argument, we will update this function signature. So what will happen? As soon as you start your strategy, you will pass a symbol. The first thing that you would have to do is get the historical data. But before that, you would need to know what is the historical data time frame and support resistance time frame for this particular symbol. We already have this information stored in the params data frame, so that should not be that difficult. So hist time frame is equal to, again, we will be using the lock function. We all know how to extract relevant value from data frame by now. So let's say we have USD CAD. So we'll say that the symbol is equal to USD CAD and then give me backtesting underscore time frame, right? Params dot symbol is equal to symbol, and then I want this backtest underscore time frame. Again, I could have used a different name, but this is essentially the candle duration we used for our backtesting, and we'll use the same candle duration for our strategy deployment. So backtest underscore time frame. So let us test it. So let me fill in a random value for symbol. All right. So now if I run this, you'll see that I've got the relevant row, but I actually want only this time frame underscore H4. So what I'll do is that I'll convert it into a list and then get the first value out of it. So if I run this now, oh, sorry, this 0 needs to be out of this. All right. So I've got the string time frame H4. Likewise, let me copy this. We also need the support resistance time frame. So let me create the variable support resistance time frame, and this would change to actually the same thing, suppress time frame, right? So if I run this for testing, we've got our support resistance time frame. So we have the two parameters. Now, before making any trading decisions, we want to see whether there is an existing position or not. Because if there is no existing position, we would then run our trade entry logic and try to get a signal. But if there is an existing position, we'll only check for the exit criteria, and if the exit criteria is met, we will place the cross position order accordingly. Being mindful of your position is very important in the strategy, so let's do that. So I think we have already imported get position data frame, have we not? Let me check it. We had put together the get position data frame code in one of the lecture videos. I think I have not included that in utility function. Let me quickly check it. I think I have not. So let me copy over that code into our strategy code. Okay, so get position df, if you recall. So let me quickly copy and paste this into our code. Ideally, we should go in the utility function, but it's okay. So open position is equal to get position df. So this will give me the position for all the symbols, alright? So why don't I run the code? I have key.txt here. Let me double check. I don't want to screw up my running strategy, so let me run this and let me actually show you how my position data frame is looking right now. Alright, so I've established the connection, so I can run the MT5 APIs now. So let me run this function, get position df. And if I run this, I don't think I have any open position in my demo account right now. Let me quickly check it. Yeah, nothing. Let me quickly paste a couple of market orders and get some positions so that you see a data frame. Okay, so I've placed a couple of orders. So now if I run this, my open position has 2 rows, one for Euro GBP and one for Euro USD. Okay, and I'm going to use a variable called long short. This would identify whether we have an existing long or a short position for a given symbol. So let me initiate this with a blank string, but based on our open position, we will update this long short variable. Alright, so now let us try to see whether for this symbol we have an existing long position, short position, or a blank position. Because Python cannot open this data frame and eyeball these rows and tell you, hey, you have a long position in Euro GBP and long position in Euro USD. We'll have to actually parse the data which is there in open position and make this decision. So first, let us check what's the length of the open position data frame. So if the length is greater than 0, meaning there is some existing position, only then check whether the current symbol that you have has an existing position or not. So open position dot symbol, is that a capital S or a small s in open position? Small s. So open position dot symbol is equal to symbol open position. Okay, so we want to check whether for the given symbol there are any rows or not. So if you recall, right now the value of symbol is USD CAD. I have not placed any order for USD CAD. So if I'll run this, I'll get a blank data frame. So let me call this data frame open position for the current currency or whatever CUR. Now, if length of this particular subset of the open position is greater than 0, then we'll have to check whether it's a long or a short position. So what does this mean? So this means for whichever symbol we are presently running the strategy that has an existing position. And how would you determine whether it's a long or a short position? So if you open position, where is position? Okay, so right now it's all positive. You see 1, 1. Let me place a short position as well. Actually, let me do it for USD CAD. Okay, so I have placed USD CAD. So if I run this, you see that now I have 3 rows. So if I open this, just see how we can identify whether it's a long or a short position. So first of all, you look at the volume. What was the volume you used? 1, 2, whatever. But volume would not tell you whether it's a long or a short position. This type would tell you. So in MT5 documentation, you will see that if type is equal to 0, then it's a long position. And if type is equal to 1, then it's a short position. So it's a bit weird. You would expect this to be type positive or negative, but here it's 0 and 1. So we'll have to get a bit creative in figuring out whether it's a long or a short position. So you can either provision for this logic here, or if you want to make your life a bit easier, let's make the change to get position data frame function so that once we pull this data, if it is 0, we'll make it 1, and if it is 1, we'll make it -1. Because once we have type as +1 and -1, we'll be able to figure out whether it's a long or a short position. So position df dot type, we'll use the numpy dot where function, which is very similar to Excel's if function. Have I imported numpy? I don't think so. Import numpy as np. So wherever position underscore df dot type is equal to 0, make that 1, else make that -1. Okay, so if I run this, okay, so now if I run this, if I open position df, which is a local variable here, you see that now type is 1 and -1, alright? So let me run this function again, and now let me rerun this open position. So now you will see that in open position, you have +1 and -1. So now we can very easily figure out whether we have a long position in the symbol or short position in the symbol. So in this case, it's fairly straightforward. In our strategy, we are not going to have multiple positions for a given symbol, but you may have a strategy wherein you have multiple positions in USD CAD. So for example, you may have a long position with volume 2 with USD CAD and a short position with volume 1 with USD CAD. So you are net long. So let us make our strategy code a bit more robust and take into account such possibilities as well. So now all that we'll have to do is check the product of type and volume for each row of the particular subset of the open position data frame. So again, visualize in your mind that USD CAD has 2 rows. So open position CUR would have 2 rows. So we'll take the product of each of the type and volume and sum it up. So if open position current dot type into open position current dot volume. So if I quickly run open position current again, and if I run this line of code, you get this, but if you had multiple rows, you would have got 2, -1 and 3 plus 2, alright? So you can take the sum using the sum function. So if I run this now, you'll see -1. So if this value is greater than 0, then we'll update long short variable that we have declared here as long. Alright, let me copy this line of code, paste it here. Let me fix the indentation. Elif, this is less than 0, then it is short. If it is 0, then we don't need to do anything because long short by default is blank. Alright, so now we have everything that we need before we extract the historical data and start implementing our logic and checking for the signals. But this lecture video has become a bit long, so let me stop it now. We'll resume with the rest of the code from the next lecture video. Thanks. Hello friends, continuing from where we left off, now we'll have to get the historical data because we want to perform the technical indicator analysis and check for the signals. Alright, so let me call this variable OHLC and let me get this function, get historical data numeric index, and then give all the parameters that it takes. So what all parameter does it take? MT5 symbol time frame, start position, num candles. Alright, so let me copy this and paste it here. So this time frame would be historical time frame. Start position by default 0 is fine. So let me remove this. And num candles 200 is also fine. So let me remove this as well. Now I'll have to get the MACD. That's fairly straightforward. OHLC. Actually, let me get the technical indicator code here as well so that we don't do any typo. Alright, where is the MACD function? Here. So it's DF MACD signal and histogram. So instead of DF, this will be OHLC is equal to MACD OHLC. Let me quickly get this and see if we are getting the correct data or not. So we've got the historical time frame. So if I run this now, let's check OHLC. Alright, so we have got the data, 200 rows. And then let me run this line. So we have also got the MACD. So now you have the technical indicator. Now you need to figure out whether you need to enter a trade or exit a trade. So for that, we'll probably have to create a function we will implement all this logic, but I'll do that in a separate function, and I'll store that in a variable called signal, and let us call that function trade signal, which will take in the current data, historical and technical indicators, and the existing long-short position. So let me actually create a placeholder for this function. So define trade signal. It will take in candle data and long-short. Right now, let me just create a placeholder. Alright, so we would generate the signal, and based on our signal, we will have to then find the position size. So getting position size is fairly straightforward. We have the function here, get position size, and all this function takes is, it takes a lot of things, okay? So let me just get this function here. So get position size, symbol, MT5. Others are default, I can leave as they are. So here, if I run this get position size for USD CAD, I'm getting 1.33. This looks reasonable. And once you get the position size to place the order, you would also need to know the support and resistance level, because that is what would be required to place the bracket order. Alright, and we have a function for that, find support resistance. It takes the symbol and the time frame. And this time frame is support resistance time frame. Other default variables can remain as they are. Alright, so support resistance. If you see, this function returns support and resistance as a list. So you would have support and resistance. So we are going to store those values in support and resistance. Find support resistance symbol and then support resistance time frame. Let me quickly test this function and see if we need to make any changes. So let me run this function first. And if I run this here, oh, sorry, I have not run this line of code. Now if I run this, yeah, I'm getting an error. Let's see what's going on. So we're using get historical data numeric index, which is using get attribute, and it takes in MT5. So this has to be a problem with incorrect signature. So let me fix this. So let us pass MT5 as an input parameter here. Let's check now. Okay, so I think I've been able to find the issue. So we changed the function to get historical data numeric index here, but we didn't change all the parameters. So it doesn't take time till is equal to none. This function actually takes the index. If you remember, it takes start position, right? So sorry about that. This function we had created for backtesting, so time till could have been an actual time, but in the strategy deployment, we are not going back in time to calculate the support and resistance. We want it as of the current date. So let me change this time till to start position, and the default value would be 0. Likewise, time till here would be start position. Alright, if I run this now I should not get an error, but let's see. Success. Okay, so you can see that we have got the support and resistance as 1.3287 and 1.3898. Let's quickly go to the USD CAD chart. What's the support resistance time frame that we have? 1 day. So let's go to 1 day USD CAD chart and see whether these numbers make sense. Alright, so this is 30-minute chart. Let's go to 1 hour chart. So the number of candles that we have considered is 100. So 100 days would mean almost more than 3 months. So I have to go till October. It was the highest value in the past 3 months. So I think this level around 1.3738, this is what it is giving us as the resistance. So the scale of this chart is very low, but because we have used 100 days to check our support and resistance levels, the code figured out that around this 1.38, there have been a lot of bouncing down in the past 3 months. Likewise, if you check for support, which is 1.3287, the past 3 months, there have been a few bounce ups from 1.32 level. Alright, once again, support resistance is something that you may want to further refine based on your requirement. But for the purposes of this code, let us continue with the current support and resistance. So now we've got everything. We've got the signal. We have got the support resistance and position size to place the order. So all that we'll have to do now is check what signal we got from the trade signal function, and based on that, take trading actions. So if signal is equal to buy, we will return signals as buy or sell from the trade signal function. We will place an order. So place bracket order. It takes symbol, volume, all these things. So place bracket order. Symbol would be symbol, volume would be position size, buy sell would be signal, stop loss price would be, it's a buy order, so it would be the support, and take profit would be the resistance. And at this point, you may want to print out the message on the console that on that specific time, so this is the placeholder for printing out the time, new, long or short, whatever, buy or sell position initiated for the given symbol. Dot format. Here we are printing out the date time. So dt dot date time dot now. Have I imported date time? I don't think so. Import date time as dt. Then signal, whether it's a buy or a sell. So on this time, new buy or sell position initiated for symbol. Alright? As simple as that. And at this point, you may also want to send yourself an email. So let us get the function send email. So in the function that I'll share with you, I have put in email ID, email password, and 2 email ID as required arguments. You can make these as default arguments and only pass the message here. So let me only pass the message. I will pass the same message. So you will get this as an email. Alright, so let me copy this. LF signal is equal to sell. Not a lot has to change here. In order, the support and resistance would flip. That's the only change you'll have to make. So print and send email, you can have the same command. In your printed message, the signal would be flipped and you will get the right message. Just one thing, you may want to change the date time format. We all know how to do that. So it is a date time object. So we can use the string format time function and then give whatever format you want the date to be printed out. So %y, %m, %d, %h, %m, and %s. So the signal can be either buy or sell or close. So let us also provision for that. LF signal is equal to close. So this would be close position. So close position symbol. This strategy is simple because we are not having multiple positions for a given symbol. So we can be a bit relaxed in how we are closing positions. But if you have other strategies, you may want to have other close order functions which take into account the specific position that you're trying to close. And as we have discussed, you can do that with close position as well. If you give specific position, you should be able to close that specific position. So here, the message would be existing long or short position initiated for this symbol. So the signal would become long short. Okay, so long short, if you see above, this is where we are storing whether for this symbol we had an existing long or a short position. So this can help us print this message whether the existing position was long or short, and then everything else would remain the same. Let me copy the print command and let me make that as an email body. Alright, and this is it. So this is your strategy. Just one thing I would urge you to do is handle any exception that you may get because of the API issue. So put all this in a try block. So let me indent this. And then in exception, if you get an exception, accept exception as print E. And you may also want to send yourself an email about the error message. So send mail. Actually, let's get a bit creative here. So placeholder for time, error received for the given symbol. Dot format, current time, and the symbol. This is actually send email. Alright, so it's always good to handle exception because there are possibilities that either your server is down or MT5 server is down. So you may get an error for any of the API calls. So it's always good to handle exception so that your code doesn't crash. And for a few things here and there, you can handle the exception. Alright, so I'll stop this lecture video Here, we still have some work to do. We have to define the trade signal. And then right now it's all function. We have not really defined how we are going to run this code iteratively. So I'll cover that in the subsequent lecture videos. Thank you. Hello friends. So let us now implement arguably the most important function of your strategy implementation code, which is generating your trading signal, whether we have to enter a trade or we need to exit a trade. And if you recall from the backtesting strategy, this part of the backtesting code delves into the given logic when we have to enter a trade, and this part of the code delved into the logic where we need to exit a trade. So we'll try to replicate the same thing. And if you recall in the last lecture video, when we were defining this function, we decided that the candle data, the open, high, low, close, and the MACD columns would be one of the inputs to this function. And also, what is the existing state for that particular symbol, whether we have a long position or a short position, because that will decide whether we want to enter or exit that particular symbol. Alright, so the first thing that we would have to do is define a variable called signal, and we will initiate it with a blank value, and we will return whatever is the signal after the end of this function. So let us define it at the outset. Now let us go down and let's see what all we need to do. So this was the logic for trade entry. If the signal is none, then we look at the MACD value of the last row. That needs to be greater than 0. The second last MACD also needs to be greater than 0. And then the 7 MACDs prior to that need to be all less than 0. Alright, so that should not be very difficult. Let me copy this MACD index. We will still need it. So let me first define this MACD index. So we have the candle data here, so I don't have to change the name. So this should be fine. So the candle data would be OHLC. Let me quickly open OHLC and confirm that the column name is MACD. It is indeed MACD. So we are fine. Now let us implement the trade entry logic. If LS, long short, is equal to blank, meaning if we don't have an existing position in a given symbol, then do this. So let me copy this whole thing. We'll probably have to modify a few things in this, but let me copy this and paste it above. Sorry, this will have to be double equal to. Okay, so now a few things we'll have to change here. There is no concept of I in this case because we are not iterating through any data frame. So all that we'll have to do is that we'll get an OHLC. So after every 30 minutes or 15 minutes, whatever is your duration of candle that you're working with, we will extract the historical data after completion of each duration. So for example, if you're trading 30 minutes, we will extract the historical data every 30 minutes. And then you would have to check the MACD value for the last row. And how do we get the last row? -1. Alright, so that's one change you'll have to make. Again, the dynamic is different in strategy implementation compared to strategy backtesting. In strategy backtesting, you are iterating through a very large historical data frame. So there you have to figure out at which point you are backtesting, and that particular point becomes the last row for you. In this case, we have got a fresh historical data frame, and obviously the last row in that particular data frame becomes my latest value, and that's what I need to work with. Alright, so this would be -1, this would be -2, and then the next 7 MACD. So this would be -9 to -2, not including -2 because we have already included -2 here. Alright, so this would be the code that I need to run. Okay, why am I getting an error here? I need to give a colon, right? So if this condition is satisfied, we change the value of signal as buy. Let me copy this and let us figure out the logic for sell if there is no current position for the given symbol. So this would be LF. And what was the logic that we had here? LF, let me copy this whole thing and let me paste it above. The last MACD needs to be less than 0. The second last MACD also needs to be less than 0. And then the next 7 MACD values need to be positive. So -9 till -2. not including -2. And if that's the case, signal is sell. Alright, so we have taken care of the trade entry criteria. Now what about trade exit criteria? Let me copy this whole thing and paste it downstairs. Let me fix the indentation. So what are the various values of LS, long and short? Alright, so if LS is equal to long, then what was the criteria? Let's go down and check in our backtesting code. Okay, so we don't need to worry about coding the trading action when stop loss or take profit is triggered because we are already implementing a bracket order. So as soon as the stop loss or take profit prices are reached, the trading action will automatically be triggered. So I don't really need to code it. So I can ignore this section of the code. Then what was the second one? Check if the MACD base signal reverse, which would imply exiting the position. Yeah, this is what I would need to implement. Actually, this is the only thing that I'll need to implement. So let me copy this and take it upstairs and see what I need to change here. Okay, so let me replace this logic with the current logic that I have copied. And what does it say? So I think we decided that we'll check the last 3 MACD values. So I-2, I-1, and I. Alright, so we can do that. So -3 till the end. So this will test the last 3 MACD values. All of them need to be less than 0. If that's the case, we will signal close. As simple as that. I don't need to have any other criterias. Likewise, let me copy this. If the existing position is short, then the last 3 values need to be greater than 0. Again, you can feel free to update the trade exit criteria if you want to check the last 2 MACDs or if you want to have another criteria in addition to this criteria. Once you understand the code flow, tweaking the code logic is not that difficult. Right? Just be careful of what you're doing. You should understand what you're doing and it should make sense. Alright, so this should be it. This should be the trade signal function. I'll just tell you to do one thing, and that may be a bit counterintuitive, but you may have to increase all these numbers by 1. So what I mean is that wherever you see -1, you may have to do -2. Wherever you see -2, you may have to do -3. And I'll tell you why right now. So let me take you to the chart. Alright, so right now the markets are closed, but let me still try to help you understand what I'm trying to do here. So when the markets are opened, let's say you're trading 30 minutes, alright? So let me get a 30-minute chart. And let's say we are all in the Eastern European time zone because that will make it easier for me to explain the things. Alright, so this was the last candle that was created. Actually, let me change this to candle. Okay, so this was the last 30-minute candle created. And you can see that the starting time was 11:30. So this candle went from 11:30 till 12. Now you will see that if you're trading in the real market and the market data is coming in with every tick. Okay, and let's assume that 12th Jan was not a Friday because I want to get the continuity. Alright, so this is the 11:30 candle. This candle was created exactly at midnight 12 at 13th of Jan. So the open, high, low, close prices that you see, they were solidified exactly at midnight. Now exactly at 12:01, you will see that another candle here is created, but that candle only has 1 second of values. So if you extract your historical data at 12:01 Eastern European time, your last candle will have only 1 second of data. And that is a big problem because all the code that we are running, we are referring to the last candle. And what we mean to do is that we need to look at the MACD of the last completed candle having 30 minutes of data. So when you extract your historical data at 12:01, you don't want your last candle to be this unfinished candle with 1 second worth of data. You want this candle having 30 minutes of data. Alright, so this is very important. I learned it the hard way. So when you're coding, make sure that whenever you are extracting historical data candles, you intentionally do it after 1 second or even 0.5 millisecond. That should be fine. Because chances are that if you extract the historical data exactly at the turn of 30 minutes, by the time you are extracting your 6th or 7th symbol, there may be a 1 second delay. So for one symbol, you may get the correct data, and for the other symbol, you may get the unfinished data of the last scan. So you will see that when I'm actually running this main function, I'll run it such that I give a 1 second time lag after completion of each of 30 minutes or 1 hour or 4 hour, whatever is my duration. After each of that time frame, I give a 1 second lag so that I know that my last candle is the unfinished candle, which I don't want. So I'll increment all these numbers by 1. Okay, so this is very important, and make sure you do that. And I'll put a comment here so that when I upload the code, you know why I did that. But it's very important to do that. You can test it. You can test this behavior as well. If there is any lag, even 1 millisecond lag in extracting your historical data from the exact time when the candle is completed, you will get the next candle which is unfinished. And you don't want to get that, alright? So this would be -4 to -1, -1 not included, -4 to -1, -1 not included, alright? And let me put that comment somewhere here. -2 refers to the last completed candle, because in all likelihood, the last candle in OHLC data frame would be an unfinished candle. Alright? So this takes care of my trading signal function. Okay, so this was very important. Let me know if you have any questions or concerns pertaining to this function. It is very important that you understand what we did in this function, because this function is the soul of a trading strategy. This function helps you determine whether you want to enter a trade or exit a trade. So this part where you are implementing the logic should completely check out. Alright, so I'll end this lecture video here. Now the only thing that needs to be done is to use the main function and make sure we run it in a way so that we are able to achieve the iterative process and we are able to trade when the markets are open. So I'll see you in the next lecture video to finish off this strategy implementation code. Thanks. Hello friends, so now we have only one thing left, and this lecture video should be the last lecture video in this series of strategy implementation lectures. Alright, so now I don't need all this, so let me remove it. Now the only thing that I need is to keep running this main function for every symbol, and I have to find a way such that it runs exactly at the time that I need it to run. For example, we can do for symbol in symbols. We have initiated symbols above when we imported the params file, right? If I run this, these are all our symbols. So I can iterate through each of the symbol and then simply run the main function by passing the symbol. But do you think this would be correct? No. There are a number of problems with this. We have to run it at specific times. So for example, let me take you back to the params input file. So if you see, we want to run USD CAD every 4 hours. We want to run GBP USD every 30 minutes. Euro USD every 1 hour, and likewise. So this is a bit complicated. Actually, this use case is the most complicated that you may get when running Forex trading. Others would be much simpler, so I've intentionally chosen this use case so that you are familiar with the more challenging use cases. Alright, so the first thing that we'll have to do is to be cognizant of the time. So I'll create a variable called start time, and that would be time.time. I think I've already imported the time package, yes. So if I run this, I will get the current time. But this time is in Unix format, which means it is in seconds. But that's fine, because all I need to do is get a counter running. So the start time would be like our start clock. And then based on the current time, we will take the difference and figure out what has been the time lapse since we started running this code. And when do we want to end our code? So that would be whatever was the start time. Plus, I would assume that you would want to run this code from the start of Monday morning all the way till Friday night when the markets close. So this would be start time plus 60 seconds times 60 minutes times 24 hours times 5 days. So the idea is that you will start running the code midnight, Monday, Eastern European time. So run from Monday AM till Friday, 11:59 PM, Eastern European time. Actually, if you recall, we want to run it 1 second or 2 seconds after the turn of the clock. There is a problem with unfinished candle, so that thing you'll have to be mindful. Okay, now we will run our loop. So while time, whatever is the current time, is less than equal to timeout. Alright, so until and unless the timeout is not reached, your code will continue to run. At least this while loop will continue to run, and then whatever is within this while loop will also continue to run. So you can either use this logic or you can do something else, because this is forex trading. It is much easier. You start trading from Monday morning and you run till Friday night. So you don't have to interrupt trading intraday. You can also get the current time. From the current time, get the day. And if that day is from Monday to Friday, you can have this while loop running. So let me implement it. So actually, rather than removing this, let me make it an AND. So both this has to satisfy and the current day needs to be between Monday to Friday. So let us see how we can do that. So within date time, there is a function weekday. So if I recall, I think this should work. Weekday, I don't know it's a function of it or it's an attribute. Let me quickly check if it's a function. If I run this, okay, so it's a function. So the weekday value can be between 0 to 6. 0 stands for Monday, 6 stands for Sunday. So if this value is between 0, 1, 2, 3, and 4, then our code will continue to run. But there is one problem here. Again, time zone. If you are not based out of the Eastern European time zone, you will have to ensure that this current time is that of the Eastern European time zone and not your current time zone. So let us make that change here. So time zone is equal to pi tz. Have I imported pi tz? Not import pi tz. Let me quickly run it. We may have to test it. So pi tz dot time zone. We have done this before, so I do not expect you to have problems here. And then for the zone, if you recall, for Eastern time zone, I had chosen Europe, Kiev. I think this should work. Let me quickly run it to see if this works. So the current time locally is 14th Jan, 6:57. If I change the time zone to the Eastern European time zone, let us see what we get. Yeah, so this is working. I am 3.5 hours ahead of the Eastern European time, so this would work. So weekday would still be the same right now because for both the time zones, it is 14th Jan. After 5.5 hours, my date would change to 15 Jan, but it would still be 14 Jan in Eastern European time zone, right? So it's very important that you make this time consistent with Eastern European time zone because that's the weekday that the trading happens, right? And if this is in 0, 1, 2, 3, 4. So right now this will give me false because right now the weekday is 6 or Sunday. So this would be false. But if it was a working day, then this expression would resolve to true. Alright, so you can either have this or this. I'll leave that to you. In this case, let me have both of these conditions to be met. If that's the case, we will first print out that we are starting the pass-through. So pass through at whatever is the current time. So time dot string format time. Let me give the format that I want to print out the time in. So %y, %m, %d, hour, minutes, and seconds. Sorry, capital S. And then we'll have to mention what time we want to print out. So time dot local time. With a time package, there is this local time function. And again, you can use dt.datetime.now as well. I'll leave that to you, what you want to use. And we don't have to be specific about the time zone here. I may want to print out time in my current time zone because this is just to create a log that at what time this iteration ran. Alright? Actually, let me quickly run this and see if this works or not. Okay, so this works fine. So now let us iterate through each symbol. So for symbol in symbols, okay, now things are going to get a bit hairy, so I want you to pay very close attention. So let's say we started to run our code. When we are starting out, obviously, I'll extract the historical data for every single of the currency. But the next iteration would not include each of the symbols. So actually, let me open the params data frame. When I'm starting out the code, all these will run, no problem. After 30 minutes, we will have only GBP USD, USD CHF, and AUD CAD, right? Because these are the only ones that have to run every 30 minutes. After 1 hour, again, these three would run. But in addition to these three, I'll also run Euro USD and AUD CHF. Alright, so because 30 minutes is the lowest common denominator, we will have to somehow find a way to encode this logic within our loop. Okay, and it's not going to be easy, so let me show you how I did it. And again, you may have different approach, but right now let me tell you my approach. So first of all, what I did is that I created another column in my params data frame and called it pass through. This is just to keep track of how many pass-throughs I've done for a given symbol. So for example, when we'll run it the first time, we will set pass-through as 1 for every single of these symbols. So I will initiate this with 0. So if I run this line of code, my params would have another column called pass-through and it will have all zeros. So now what we will do is that we will first get the pass-through value for each of the symbol. So again, we know how to get a given value from data frame. So let's say I want the pass-through value for USD CAD. I'll look up the symbol column. If it's USD CAD, then I'll get the pass-through. Alright, so we have done that a number of times, so I do not anticipate you to have any problems with this. Params.lock, params.symbol is equal to symbol. And once there is a match, all I want is the pass-through column. And then I'll convert it into a list and extract the single element from it. Alright, so I think we already have the value of symbol saved, USD CAD. So if I'll run this, I should get a value of 0. Alright, because we have initiated the pass-through variable for every single symbol as 0. Likewise, let me get the time frame variable. So let me copy this, paste it here. Instead of pass-through, this would be backtest underscore time frame. Backtest time frame. Alright, so we have got the pass-through variable and the time frame variable. Now is the trickiest part. So what we will do is that we will subtract the current time from the start time. So this difference would be in seconds. So let's say it has been 1 hour, like 1 hour and a few seconds. So the difference between the current time and the start time would be 3600 something, right? Let's say 3603. To check whether we want to run the 30-minute time frame or not, I'll take that difference divided by 1800. 1800 seconds stands for 30 minutes, and then check for the quotient. So let me do it. That will make it a bit more easier to explain. So if time, which is the current time, minus start time, the whole thing divided by 1800, and I want to get the quotient. So this in Python, // gets you the quotient. So for example, if you want to test 9 quotient of operator 2, this would give me the value of 4. Alright, just like ampersand give us the remainder. So this would give me 1. Alright, // gives me the quotient. So if this value is equal to PT, so bear with me right now. So right now PT is 0. So obviously when we start out, this condition would match. But in addition to this time frame and TF is equal to time frame M30. If both these conditions are met, print passing through for symbol. And then we will run the main function for that particular symbol. And lastly, we will have to increment this pass-through variable for that particular symbol by 1. And how do we do that? Access that particular cell in the data frame. So params.lock symbol is equal to symbol, pass through, plus is equal to 1. So right now let me run this line of code for you, and you can see that the USD CAD would become 1. So if I run this and if I open params, you will see that USD CAD has become 1. Let me again make this 0. Just wanted to show you, that's why I ran it. We have reset this column to 0. Alright, so what did I just do? Again, think about it. When you started running this code, when you come here, time.time would be, say, 1 second, right? So this value would be 1. So time.time minus start time would be like, say, 1 or 2 seconds. Alright, so when you divide 1 by 1800, the quotient is going to be 0. So this would match because we are starting with 0. So we will run the main function, which is the actual strategy for this given symbol, USD CAD, and we will increment the pass-through variable by 1. So USD CAD would become 1. And likewise, the same thing will happen for all the symbols. So let's say the whole thing took 8 or 9 seconds, right? So the second iteration would start, but at that time, this will not be triggered. Why? Time.time minus start time would still give us the value 0, but this PT has become 1. So this would have to become more than 1800 for PT to become 1 and this whole condition to be triggered. Okay, so think about it. It's a bit involved logic, but all that I'm doing is that I'm forcing for M30 time frame to wait for 1800 seconds to trigger the next iteration. And likewise, we'll have to do the same thing for every single time frame that is present. So let me copy this piece of code and let me paste it here. So we've taken care of 1800. What is the next biggest duration in my params? So after M30, there is H1. After H1, there is H4 and D1. So I have only 4 time frames, M30, H1, H4 and D1. So that's fine. So for H1, this would become 3600, right? Likewise, let me do the same thing for H4. For H4, this would become 36 times 4 is what? 14400, right? 14400. Do I even have D1? Let me double check it. Did I look at the right column? I actually need to look at backtesting time frame. There is no D1. So D1 I'm only using for support resistance. Sorry about that. So M30, H1 and H4. These are the only 3. Alright, so this should take care of each time frame. But this is not done. We don't want to continually run these code bits. Once it has done a pass-through, because the minimum duration is 30 minutes, we may want to wait for 30 minutes before restarting the loop. Alright, so once the pass-through for each of the symbol is complete, let my code relax a bit. So time.sleep, we need to wait for 30 minutes, but again, think about it. While running this for loop, it may have taken your Python code 3, 4 or 5 seconds, right? So we have to subtract that 3, 4 or 5 seconds from 30 minutes or 1800 seconds. So how do we do that? 1800 minus whatever is the current time, time.time minus start time. Let me wrap this in a bracket. What we'll do is that we will divide it by 1800 and find the remainder this time, right? Very important. So this number will tell me whatever number of seconds it took to run this loop for symbol and symbols, alright? Let me make this float because sometimes it may give you problem because this number would be float. So that's pretty much it, alright? And just to be on the safe side, let us put the whole thing under a try exception block just to prepare for any eventuality. So in case there is any error, we will print out the exception, right? So except exception as E, print E, and then exit. Alright, so this is it. This will take care of your execution, taking into account different execution frequency for different symbols. So this use case is probably the most complex. For most strategies, pretty much all the symbols have the same running duration. But if you have use cases like this, if you understand how to manipulate the time using the start time and the current time, then you should be able to implement pretty much any execution logic. Just one thing before I close off the strategy implementation section is about implementing a fail-safe measure. Again, different people may have different fail-safe measures or different kill switch criterias, but somewhere here, after each iteration of this while loop, you may want to extract your account balance or your current daily P&L or equity or whatever. And then here, based on the logic, you may implement a kill switch. If you come out of this while loop, your strategy ends. If you get your current P&L or whatever, right? Just write a function. It's very simple. We have already discussed it. So current P&L or current equity or whatever. Have a simple logic here. If, let us call it CP or whatever, current P&L. If CP is less than kill switch threshold or something like that, you have to define your kill switch threshold, $500, $1,000, $5,000, whatever. If that's the case, break, right? So this will break out of this while loop. Okay, so right now I have not defined the current P&L and your kill switch threshold. So obviously I'm getting errors. But if you want to implement something like that, you can very easily do that. And I leave that to you because different people have different risk appetite. And these things are quite simple. All right, so this is how we implement the strategy. I'm going to share this code with you. Go through it. If there are bugs, let me know. I'll fix it. And before deploying it on your broker platform, run it on your demo platform. So whatever is your demo key, first run it on your demo account. See if it is working fine. Test for any bugs, etc. Fix them and only then deploy it in the real market. So in the next section, we'll cover about how you can deploy a strategy on cloud. And I recommend that once you have tested your strategy enough on your demo platform, do deploy it in the real market in cloud because that gives you a lot of flexibility that we'll learn about in the next section. But right now, if you have any question pertaining to this implementation, do reach out to me because it's very important that you have a thorough understanding of every portion of this implementation code. Thanks a lot. Hope you enjoyed this lecture. Thank you.